Hello students, I have come up with yet again another video which illustrates logarithmic differentiation, but this time we will have a little bit different angle of solving. Everyone knows that suppose we have to take an example. Suppose you have to differentiate x to the power sin x. You have to differentiate this function. You have to find derivative of this function, or I'll write ddx of this function is equal to question mark. So in order to solve this, since it is function raised to function, I'll take, wait just a minute, solution. Generally, what is the procedure? We'll take let y is equal to x to the power sin x, and gradually we will apply natural logarithm on both sides. Then it will become log of x to the power sin x, and this sin x can be brought it here down. Therefore, log y can be written as sin x into log x, so that it's easier to deal with elementary product of two functions. Then differentiating with respect to x implies derivative of logarithm of y is 1 upon y into dy by, or derivative of y with respect to x. Chain rule we are applying. Then product rule, here we have to apply product rule. This is first function, this is second function. Sin x, derivative of log x, it is 1 upon x, plus log x into derivative of sin x is cos x. And now this y can be transferred, because y we have introduced, to dy by dx will be equal to y times what is y? X raised to sin x into sin x plus, if we can take cross multiply, we take common denominator x into cos x, then into log x, completely divided by x will come, and this power can be put it in the x, we can adjust it, sin x minus 1 you can write, or else this is the final answer. This is a proper way of solving, but there is a different angle. Everyone knows that this e raised to log x is always equal to x. This e and log are anti-functions. They cancel each other, and x is as it is getting stored back. So, and log of e raised to x is also equal to x. Always remember, logarithmic of e is 1. So because of laws of logarithm, this will come down. It will become x log e is 1. So because of this particular thing, what we are doing, suppose if at all there is a function like this, suppose take another function, a small example we'll take. Example, suppose we have to differentiate x to the power sin x, only you take the earlier example. So this can be written, if you want to differentiate this, suppose you want to differentiate this, so directly you can write, still without differentiating, first you write x to the power sin x as e raised to log of x to the power sin x, without making any kind of change, because e raised to log of anything is that thing. E raised to log of a will be a, e raised to log of x will be x, e raised to log of sin x will be sin x, e raised to log of y will be y, e raised to log of z will be z, e raised to log of x raised to sin x will be x raised to sin x. Now because of this, actually it looks like this, ddx of e raised to log of x to the power sin x. So this sin x can be brought in front of log. Okay, so this becomes e raised to sin x log x. So here there is a product of two functions, and what is derivative of exponential function? Same as that only. It is same, e raised to sin x into log x into derivative of sin x and log x. It gets so simple, so simplified. And e raised to sin, this actually is what? X to the power sin x, because this has been, actually we can write it like this, no? E raised to, again you write it like this, e raised to log x to the power sin x, and now you differentiate. First function sin x, derivative of log x plus log x derivative of sin x, that is cos x. Finish. Your answer is over, because this is nothing but the given problem. We have written this like this now. E raised to log x to the power sin x is actually is equal to what? X to the power sin x only. E raised to log of anything, e raised to log of anything is that thing. So I will write x to the power sin x into whatever is the bracket. Everything you have to write. So this is how you can solve. This is another angle of solving. So any doubt you can ask. Using exponential thing, we have used logarithm. This is the basic fact. E raised to log of anything is that thing. E raised to log of x is x. So using logarithm also you can apply, or indirectly we are using logarithm. But first we have done anti-log, and then in that particular thing log properties will apply. That you understand properly, and then you solve different problems. Okay.